Hey guys, what's up? So here's the deal. I think you guys are doing awesome in class, so I'm gonna send you guys on your own way today. You're gonna check out this video, and then you're gonna check your work. There's a couple things I want you to do. First, your goal is to make sure that these bonds are correct. Okay. I'm gonna do the first two together. You're going to do the rest. When you're done, you're gonna jump back into the main room, and then I'm gonna come into your breakout room. Someone tell me that you're done. I'm gonna jump to your breakout room to get these done. So in order to bond these, you had to look at your first two slides, your blue slide and your purple slide. Okay. So looking at your blue slide, you need to figure out how many valence electrons lithium and oxygen have. Okay. So think to yourself right now as I'm writing this, how many valence electrons does lithium have? Okay, lithium has one valence electron. So lithium, this is the Lewis dot structure, has one valence electron. Oxygen has six valence electrons. Here's oxygen in the red. Okay, we need to figure out how many lithiums go to how many oxygens. Each molecule or each atom likes having 8 electrons in their outermost shell. They'll get there by either losing the electron or gaining the electron. So for oxygen with 6 valence electrons, it is 2 away from getting to 8. Okay? Lithium can only offer it 1 valence electron, so that will not complete the shell of 8. So lithium will give oxygen its 1 valence electrons. However, oxygen is not happy. It still has one spot remaining. 1, 2, 3, 4, 5, 6, 7. Remember the octet rule? It wants to get to 8. So how many more lithium do I need to fill oxygen's outermost shell? You would need 1 more. Okay? Lithium gives oxygen 1 more. Okay? So how many total lithiums did I need with 1 valence electron to bond with oxygen to fill its outer shell? You need 2 lithiums, this is a subscript, to every 1 oxygen. Here is your chemical formula. Okay? Li2O. This is the dot structure for it. Okay? Instead of doing the dot structure every single time, you are able to do a crisscross method. To do that, you need to know the oxidation numbers for each one of oxygen and lithium. That would be your purple slide for this activity. Lithium has an oxidation of +1. Oxygen has the oxidation of -2. I'm going to take the oxidation number of 2 from oxygen, and I'm going to bring it down to the subscript of lithium. Okay? Then I'm going to take lithium's oxidation, and I'm going to bring it down to the subscript of oxygen. Now I'm going to combine them because they're bonding, and I'm going to write my formula. Li2O. Now there's a 1 here, but you do not have to write the subscript of 1. So I'll end up with Li2O. Okay? This would be our final product when those two merge. To get this, I need to find out how many valence electrons of 1, and then what the oxidation of lithium would be, which would be +1, to figure out how to bond this. Okay, I'm going to do one more for you. Magnesium and oxygen. Look up magnesium's oxidation. look up oxygen's oxidation. Magnesium's oxidation, because it's in group 2, has 2 valence electrons. It's going to want to lose those 2 valence electrons to gain a charge and oxidation level of +2. Oxygen in group 16 has 6 valence electrons and is willing to gain 2 more negative electrons, giving its oxidation -2. So using the crisscross method, you should see one thing right away, that +2, -2, that already makes a neutral molecule. But if we did the crisscross method, think of these as a ratio. And you might be saying, I'm going to get Mg2O2. But think of them as a math ratio. For every 2 magnesiums, I need 2 oxygens, which is the same thing as saying for every 1 magnesium, I need 1 oxygen. When magnesium and oxygen bond, this is our chemical formula. Okay? Since magnesium is a metal, oxygen is a nonmetal, this is going to form an ionic bond. They're not going to share the electrons. Magnesium is going to give the electrons to oxygen. Oxygen is going to have that and gain a -2 charge. Magnesium is going to become a +2 ion. The oxygen will become negatively charged. The magnesium will become positive charged. The opposites will attract, and they will grab onto each other. Okay? And we get magnesium oxide. All right, so these two. What I want you to do is do 3, 4, 5, 6, 7. After you're done with that, I want you to go back up to the very first slide. I would like you to define those following terms I left you. After you define those terms, I want you to go back to the purple slide, and I want you to label cation and anion for each one of those elements. Okay? Do the definitions. Finish this first. Do the definitions on the first slide. Then jump to the purple slide and label them cation or anion. All right? When you guys are done, I'm going to come in and check your work. I'll make 1 or 2 of you bond with each other. Please try to work together and ask each other questions as we move forward. And if there's not a teacher in the room, you guys can bounce back and forth. All right? So I'll see you at the end of class.